Example, it is find the joint equation of lines passing through point 1, 2 and parallel to the coordinate axis. Okay. Here, these are the simple problems. Ask it is 2 marks or 1 marks. Here, the lines passing through point 1, 2 and parallel to the coordinate axis. Okay, here the equation of lines passing through point 1, 2 and parallel to the coordinate axis. Here, parallel to the coordinate axis, one line is parallel to the x-axis and one line is parallel to the y-axis and passing through point 1, 2. Therefore, the equations are directly can be written as it is point x, y. Therefore, equations are x is equal to 1 and y is equal to 2 are the equations when line passing through point and parallel to the coordinate axis. Here, okay, see, it is the coordinate axis x and y. Line passing through point here 1, 2, 1 and it is 2. 1, 2. Okay, here 1, 2. Parallel to the coordinate axis, it is a parallel to the y-axis and this line is parallel to the x-axis. Therefore, it is y is equal to 2 and it is x is equal to 1. X is equal to 1 and y is equal to 2. Here in the question, here we ask the parallel or perpendicular. When the asked question lines are perpendicular to the coordinate axis, then concept is the same. When this line is a parallel to the y-axis, therefore it is a perpendicular to the x-axis and this line is a perpendicular to the y-axis, therefore it is a parallel to the x-axis. Therefore here word parallel or perpendicular, in any case here equations are same. X is equal to 1 and y is equal to 2. When here point 4, 3, then x is equal to 4, y is equal to 3. When point minus 4, 3, then lines passing through minus 4, 3 and parallel to the coordinate axis, then equation is x is equal to minus 4 and y is equal to 3. And when the ask the question lines passing through minus 4, 3 and perpendicular to the coordinate axis, then also x is equal to minus 4 and y is equal to 3. Okay, are the equations. Now here passing through point 1, 2 and parallel to the coordinate axis, therefore equation of lines x is equal to 1 and y is equal to 2. Therefore we can write x minus 1 equal to 0 and y minus 2 equal to 0 and therefore combined equation. Combined equation is, it is x minus 1 and y minus 2 is equal to 0. Then it is xy minus 2x minus y and plus 2 is equal to 0 is the second degree equation. Here a equal to 0 and b equal to 0, but it is 2h is equal to 1. It is degree 2, degree 1, degree 1 and here degree 0. It is a second degree equation, is required combined equation. Okay. Now we see the second example. Lines passing through point 3, 2 and parallel to the lines x equal to 2 and y is equal to 3. Here, given lines x equal to 2 and y is equal to 3. Suppose here x is equal to 2 and y is equal to 3 lines. X equal to 2, it is x equal to 2. Y equal to 3, it is y equal to 3. Are the given lines. Okay, and the required lines are parallel to these two lines. Here, these two lines are parallel to the coordinate axis or perpendicular to the coordinate axis. Means required lines are also parallel to the coordinate axis. We say the parallel to the coordinate axis or both are perpendicular to the coordinate axis and passing through point 3, 2. Okay, that means here it is y x is equal to 2, then here 3 and here 2. Here dotted lines are our required lines. It is point 3, 2. Therefore, it is y equal to 2 and it is x equal to 3. That means equation of line x equal to 3 and y is equal to 2. Question same. In the last example, parallel to the coordinate axis, and here parallel to the line x equal to 2. X equal to 2 is perpendicular to the x axis, that means parallel to the y axis. Y equal to 3 is perpendicular to the y axis, therefore parallel to the x axis. That means the line passing through point and parallel to the coordinate axis. In the question, same as the last example. Okay, now here the equations of lines passing through point 3, 2 and parallel to the lines x is equal to 2 and y is equal to 3, that is parallel to the coordinate axis are x equal to 2 and y is equal to 3. Therefore, x minus 2 equal to 0 and y minus 3 equal to 0. Therefore, combined equation. X minus 2, y minus 3 equal to 0. Therefore, xy minus 3x minus 2y and plus 6 is equal to 0 is the combined equation of these two lines. Okay, here next in the example when we ask find the combined equation of the coordinate axis. Okay, here the example, find the combined equation of coordinate axis. Therefore, equation of coordinate axis are x equal to 0 and y equal to 0. Find the combined equation of coordinate axis. X equal to 0 and y equal to 0 are the equations of the coordinate axis. Therefore, their joint equation it is x into y equal to 0. It is the joint equation of the coordinate axis. Okay. X into y, it is joint equation of the coordinate axis. Therefore, coordinate axis, here it is y equal to 0 and it is x equal to 0. These are the two lines. Therefore, their joint equation it is xy equal to 0. Find the joint equation of lines which are at a distance nine units from y-axis. Okay, here. First find the equation of lines. The equations of lines which are at a distance 9 units from y-axis. Okay, here, distance of line from the y-axis here. Distance of line from the y-axis is a 9, therefore it is a x is equal to 9, and distance it is a 9, but it is x is equal to minus 9. Okay, therefore equations are x is equal to minus 9 and x is equal to 9. Therefore x plus 9 equal to 0 and x minus 9 equal to 0. Therefore joint equation is x plus 9 and x minus 9 equal to 0, and therefore it is x square minus 81 is equal to 0. It is a joint equation of lines. X square minus 81 equal to 0. It is a quadratic equation. Quadratic equation is also second degree equation. Okay. Now next example. Equations of pairs of opposite sides of a parallelogram are x square minus 7x plus 6 equal to 0 and y square minus 14y plus 40 equal to 0. Then find the joint equation of its diagonals. Find the joint equation of its diagonals. Now here given are the four equations. Here these are the two equations and these are the two equations. X square minus 7 x plus 6 equal to 0. It is a second degree equation. Therefore here it represents two lines which are the opposite sides of the parallelogram. And it is also two lines which are also other two sides of the parallelogram. Now first we separate these lines. It is a quadratic equation. Okay, second degree equation in the form of the quadratic equation. Now here given lines are, it is x square minus 7x plus 6 equal to 0. Therefore take the factors here. X minus 6, here 1 u. It is x minus 1 and x minus 6 is equal to 0. Therefore x minus 1 equal to 0 and x minus 6 equal to 0. Therefore x equal to 1 and x equal to 6. X equal to 1 and x is equal to 6 are the opposite sides are the opposite sides of parallelogram. Okay. Now x is equal to 1 and x is equal to 6. Here it is x and it is y. It is 1, x is equal to 1. It is the one side of the parallelogram, that is x is equal to 1 and x is equal to 6. Suppose here x is equal to 6. X is equal to 1 and x is equal to 6 are the two sides of the parallelogram. Okay. Now, and the second equation, y square minus 14y plus 40 is equal to 0. Take the factor, it is minus 4 and minus 10 is equal to 0. Therefore, y minus 4 equal to 0 and y minus 10 equal to 0. Therefore, y is equal to 4 and y is equal to 10 are opposite sides of parallelogram. Are opposite sides of the parallelogram. Y equal to 4. Now here y equal to 4 and y equal to 10. Now here x equal to 1 and it is y equal to 4, therefore a 1 comma 4. Here b 6 comma 4. Here c 6 comma 10 and it is d 1 comma 10 are the vertices of the parallelogram a, b, c, d. Therefore, the vertices of parallelogram A, B, C, D are, okay, vertices can be written as here. A, it is 1 comma 4. B 6 comma 4. C 6 comma 10 and D 1 comma 10, okay, are the vertices of parallelogram, but we find the joint equation of its diagonal. Therefore AC and it is BD are the diagonals. First we find the equation of this diagonal. AC and BD are the diagonals. AC and BD are the diagonals of parallelogram. Okay, here AC and BD are the diagonals of parallelogram. We want to find the joint equation of the diagonals. First we find the equation of diagonal. Therefore AC diagonal passing through 2 points, that is A and C. Therefore we find the equation of line AC. Then BD passing through point there B and D. Therefore we find the equation of line BD. And when we find the equation of BD, then equation of BD and AC, and then find the equation of combined equation of lines AC and BD, that is the combined equation of diagonals of parallelogram. Okay. Now first find the equation of AC. Therefore the equation of diagonal AC is, here equation of line passing through 2 points, it is x minus x1. Equation of line passing through 2 points, it is x1 comma y1 are the points and x2 comma y2 are the points. Therefore equation x minus x1 upon x2 minus x1 and y minus y1 upon y2 minus y1 are the equation of lines. Therefore here point AC, therefore A and it is C, it is x1 y1 and it is x2 y2. Therefore equation of line is x minus x1 upon x2 minus x1 is equal to y minus y1 upon y2 minus y1. It is x1 y1 and it is x2, y2. Therefore equation becomes x minus 1 upon it is 5 is equal to y minus 4 upon, here it is 6. Okay, therefore 6x minus 6 is equal to 5y minus 20, that is 6x minus 5y, then here plus 0, it is plus 14 equal to 0. It is equation number 1. It is the first diagonal. Now the equation of second diagonal, and equation of diagonal BD is BD, it is x1 y1 and it is x2 y2. Therefore x minus x1 upon x2 minus x1 is equal to y minus y1 upon y2 minus y1. x1 y1 and it is x2 y2. x minus x1 upon y2 minus y1 and x2 minus x1 and y minus y1 upon y2 minus y1. Therefore this can be written as x minus 6 upon minus 5 is equal to y minus 4 upon 6. Okay, therefore this can be written as cross multiplication. It is 6x minus 36 is equal to minus 5y plus 20, that is equation, it is 6x plus 5y and it is 20, here it is 56 minus 56 equal to 0. It is equation number 2. And now we find the combined equation of equation number 1 and 2. Therefore the combined equation, that is the combined equation of diagonals, 6x minus 5y plus 14 into 6x plus 5y minus 56 is equal to 0. Now take the calculation. Here 36x square plus 30xy, it is 30xy, and minus 6 into 56, 6 6 are 36, carry 3, 6 5 30, it is 33x. Okay, now multiply by minus 5y, then minus 5y 6 minus 30xy minus 30xy, then minus 25y square, then minus 5 into minus 56, it is plus 5 into 6, it is 30, and 5 into 5 25, 25 plus 25 plus 30, it is 28y, it is plus. Now 14 multiply by this, again here plus, okay, 14 into 6, it is 84 x plus 70y, and now it is 14 into 56 minus 14, it is a 4, carry 8, 7, 70, 78 is equal to 0. It is the calculation, and therefore last answer 36x square, xy is a term, 30, it is minus 30, okay, 30xy, okay, and minus 30xy get cancelled, plus y square, it is minus 25y square, okay, xy get cancelled, it is minus y square, then x, it is 336 and it is 84, okay, 6 minus 2, and then 13 minus 5, it is 252x, then y here 280 and 70, it is both are plus, it is 350 350y, and last minus 784 is equal to 0 is the required combined equation. Now next, it is a required combined equation. Now next example. Next example. If the line x plus 2 equal to 0 coincides, if the line coincides with one of the lines represented by the equation x square plus 2xy plus 4y plus k is equal to 0, then show that k equal to minus 4. Now here given line x square plus 2xy plus 4y square plus k equal to 0. Here given that x plus 2 equal to 0 is one of the line of 1. Let another line, it is consider ax plus by plus c equal to 0 be the other line. Then we know that the combined equation of these two lines represent this line, because one of the line is given and other line we consider this line. Therefore the combined equation of these two lines, it is this line. Okay, now we find the combined equation. Therefore combined equation is x plus 2 into ax plus by plus c is equal to 0. Now take the multiplication. It is ax square plus bxy, it is x plus 2, it is bxy plus cx, okay, then plus 2ax plus 2by and plus 2c is equal to 0. This equation can be written in terms of general second degree equation, that is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c. Now here ax square plus xy is written here bxy, then y square neither, then x, it is x plus c plus 2a into x plus y, it is 2by plus 2c is equal to 0. It is equation number 2. Here, equation 1 is a combined equation of these two lines, and equation 2 is also the combined equation of these two lines. That means equation 1 and 2 represent the same line. Therefore, equation 1 and 2 represents same line. Therefore, their coefficients are proportional. Coefficients are proportional. Here, x square, therefore we can write 1 upon a, coefficient of x square is equal to xy 2 upon b, it is xy, then x, here x equal to 0, then y equal to 4 upon 2b is equal to, then constant k upon 2c, and here c plus 2a becomes 0 because here x is absent. Therefore, it is c plus 2a, coefficient of x, it becomes 0. Then coefficients are proportional. Therefore, we can write here 1 by a is equal to, it is 4, 2 by b is equal to, again it is 2 by b is equal to k by 2c, and it is c is equal to c plus 2a equal to 0. Now here 1 by a is equal to 1 by 2b, therefore a is equal to b by 2, or a is equal to 2a is equal to b, 2a is equal to b. Okay, and here 4c is equal to bk. Here 4c is equal to bk, and it is c plus 2a is equal to 0. Then here 2a is equal to b, and here c is equal to bk by 4. Okay, and c plus 2a is equal to 0. Then it is 2a and it is c. Therefore, we can write b plus bk upon 4 is equal to 0. Therefore, bb get common and cancel. Therefore, 1 plus 4k by 4 is equal to 0. Therefore, k by 4 is equal to minus 1, and that is k is equal to minus 4. It is the solution. Okay, calculation थोड़ा शॉर्ट मध्ये करता येते, जसं करायचं तसं करायचं. It is k upon 4 is equal to minus 1, therefore k is equal to minus 1. Okay, now I see the next example. Next example, find the separate equation of the lines represented by represented by the equation x minus 2 square minus 3 x minus 2 y plus 1 and plus 2 into y plus 1 whole square equal to 0. Now we find the separate equation of these lines. Here when we expand addition subtraction, then we get the general second degree equation. Okay, there is no formula for the separation of the general second degree equation. Okay, therefore, but this equation, it is a form of homogeneous equation. It is a second degree homogeneous equation. Here ax square plus 2xy plus by square equal to 0. It is a homogeneous equation in x and y, but it is second degree homogeneous equation is in x minus 2 and y plus 1. It is a second degree homogeneous equation. Here it is x minus 2, y plus 1, y plus 1, x, y. Therefore, it is a second degree homogeneous equation in x minus 2 and y plus 1. It is second degree homogeneous equation in x and y, but it is second degree equation in x minus 2 into x minus 2 and y plus 1 in the form of this. Okay, therefore, for this, here it is a given equation x minus 2 square minus 3 into x minus 2 y plus 1 and plus 2 into y plus 1 whole square equal to 0. Here x minus 2 and y plus 1 in terms of one variable, here put x minus 2 is equal to suppose capital X, notation कोणतेही घ्या, इथे a आणि b घेतलं तरी चालतंय, कोणतेही घ्या नोटेशन, and y plus 1 is equal to capital Y. Okay, notation कोणतेही घेतलं तरी चालतंय. Therefore, this equation becomes x square minus 3xy and plus 2y square is equal to 0. Okay, now it is a second degree homogeneous equation in capital X and capital Y. Now factorize. Multiplication 2 plus 2, addition minus 3. Therefore, you can write x square minus 2xy minus xy plus 2y square is equal to 0. Therefore, x minus 2y, then get minus y common. Again, x minus 2y is equal to 0. Then x minus y, and it is x minus 2y is equal to 0. Therefore, we can write x minus y equal to 0 and x minus 2y is equal to 0. Okay. Now, here, these are the separate equation of this line, but we find the separate equation of this line. Therefore, it is capital X is equal to x minus 2 and capital Y is equal to y plus 1. Therefore, we can write it is x minus 2 minus y plus 1 is equal to 0. X minus y and x minus 2 minus 2 into y plus 1 equal to 0. Then x minus 2 minus y minus 1 is equal to 0 and x minus 2 minus 2y minus 2 equal to 0. Therefore, x minus y minus 3 equal to 0 and x minus 2y minus 4 equal to 0 are separate equations of 1. Okay, here. Now, same example, we see the second. Ten x plus 1 square plus x plus 1 into y minus 2 and minus 3 y minus 2 square equal to 0. Now here, it is a second degree homogeneous equation in x plus 1 and y minus 2. It is second degree equation in x and y. It is second degree homogeneous equation in x plus 1 and y minus 2. Now the given equation, it is 10 x plus 1 square plus x plus 1 y minus 2 minus 3 into y minus 2 square. Here put x plus 1 is equal to x and y minus 2 is equal to capital Y. Therefore, we can write 10x square plus xy and minus 3y square is equal to 0. Now, it is a second degree equation in second degree homogeneous equation in capital X and capital Y. Therefore, factors here 10 into minus 3 minus 30. Addition plus 1, that is plus 6 minus 5. Therefore, 10x square plus 6xy minus 5xy and minus 3y square is equal to 0. Therefore, we get common 2x. Then here 5x minus 3y. Here get common y. Therefore, 5 minus y get common 5x. Here it is plus, and it is plus 3y is equal to 0. Therefore, 2x minus y and 5x plus 3y is equal to 0. 2x minus y equal to 0 and 5x plus 3y equal to 0. Okay. Therefore, put the value of capital X and capital Y. 2 into x plus 1 minus y, that is y minus 2 equal to 0, and 5 into x plus 1 and plus 3 into y minus 2 equal to 0. Now take the calculation. 2x plus 2 minus y plus 2 is equal to 0, and 5x plus 5 plus 3y minus 6 is equal to 0. Now it is 2x minus y plus 4 is equal to 0, and 5x plus 3y minus 1 equal to 0 are separate equation of 1. Okay, here it is a equation in second degree homogeneous equation form, but not in x and y. It is x plus 1 and y minus 2. Okay, therefore put x plus 1 is equal to x and put y minus 2 is equal to y. Then it is a form of second degree equation in x and y. Okay, then solve and then put the values of capital X and capital Y. We get the required it is